Get your torque sockets up because today I'm going to show you what's inside of this BMW N20 engine and how it works. Now this is a 2-liter turbocharged 4-cylinder engine, supposedly a replacement for their beautiful inline 6 engines. However, these engines have a plethora of fatal problems. This particular one is supposedly completely seized up. It's out of a 2015 BMW X3 with 230,000 kilometers on it. Alright, so the first part of this teardown is going to be removing the intake. These are 11mm bolts, guys. Pull this off. First of all, nothing fancy with the intake. It's just one giant bowl. There's no flaps or any electronics on here. Surprising for a BMW, they didn't overcomplicate it. See the back of those valves? There's a lot of carbon back there. So I'm going to take these valves out at the end of the video and we'll have a closer look and talk about direct injection. I don't have the right filter socket for this, but I do want to take a look at the oil filter. So I'm going to have to make my own tool. I got another screwdriver on there. Let's take this oil filter housing off. Let's see what the filter itself looks like. Well, I don't notice any particles inside of there, so it's not an oil related failure just yet. Interestingly, they've integrated the oil cooler into the radiator inlet over here, and that's going to cool the oil that's getting filtered off. Next, going to remove that. That off. Very simple. We've got oil in, oil out, straight from the filter, and we've got coolant in and coolant out. And next I'm going to remove this oil filter housing. The last bolt here is bolted from the back. Leave it to the Germans because I could have easily got it from here. And I can't even get a socket on there. I'm going to have to remove this inlet here. And take off this oil filter housing. Turning my attention over to the top here, this is a direct injection pump. Now on the exhaust camshaft, there is a lobe here that's going to press up on this spring. That's going to create a pumping action inside of this little pump here to take low pressure fuel coming from the tank and pressurize it to many thousands of psi. It's going to go to a fuel rail which is attached here to direct injectors which would sit inside of this cavity. That's going to directly inject fuel into the combustion chamber for optimal combustion. Although direct injection is very controversial because it does cause that carbon buildup that we saw on the valves. This ignition coil out. This is the connection point for the ValveTronic motor. Now I'm going to zip off all the E10 bolts that are holding the valve cover onto the head. Now the back here we've got the vacuum pump. Now turbocharged engines don't produce enough vacuum at low boost to power the brake booster, so they need a more reliable source. There we go. Now you can hear the farting sounds, but this vacuum pump is driven off of the intake camshaft and it's just going to provide vacuum pressure over here. Modern cars wouldn't need this because they use electric brake boosters and not vacuum ones. Before I can get the valve cover off, I got to remove the intake variable valve timing control solenoid. These are just little plungers that plug into the variable valve timing gear. See if we can get the valve cover off now. Inside the valve cover, nothing interesting except we do have the PCV system integrated inside of here through these holes. There's a baffle inside of here as well as a diaphragm, and then that leads out to this here, which is going to eventually go to the intake to clog it up. And behold, we have the N20's timing setup. So you can see here, this actually is going to slide in and out in order to service it as there's no cover on the front here. Now these timing guides are absolutely notorious for getting broken down and stuck down in the sump. These here are the intake and exhaust variable valve timing gears respectively. You can see there's a little push button and that's going to activate the oil control solenoid which is inside of the gear itself. Now back over on the exhaust side here, you'll see that we do have these little buckets. I'm going to remove that next. And you can see this is where the spark plugs would sit and the direct injectors would sit down below. There's another cage here for the direct injection pump. And you can see this is the lobe here that powered that direct injection pump. Behold the intake camshaft valvematic system of this N20 engine. How it works is we've got our intake camshaft which is tied to the timing chain, and then we have an eccentric shaft over here which is controlled by this gear, which in turn is controlled by an electric motor. So in essence you don't need a throttle body because the amount that you turn this eccentric shaft determines how much the valves are pressed down. So here's a close look at that motor mechanism. It actually sits down inside of the head. Now it's got a little spiral gear on it, and that's what's going to interface with this half moon gear over here, and that's what's going to turn this eccentric shaft. We just loosen these cams off before we do anything with the timing. Looks like this is an oil feed pipe that comes in here. Just going to remove it. The hex drive into the actual motor head. And you see as I rotate that, how that half moon gear rotates. And I can rotate this eccentric shaft all the way around. Now that half moon is going to rotate this eccentric shaft, and you'll see that it's got its lobe on it over here. Then we've got the camshaft, which has its normal lobe on it over here. Now we've got our typical roller arm that has its hydraulic adjuster, and that's going to press down on the valve. But in between here, we've got this arm, which is what's going to relate the motion between the eccentric shaft and the camshaft, and it's going to give you the final motion if this valve is going to open or not, regardless of the position of the camshaft. Now right now the valve is in its highest most position and its valve is shut. Now as I rotate this eccentric shaft, you'll see that this middle arm here is going to move. And it's also changing the position of where this rocker arm is. You see it's actually pressing it down further and further to open up that valve. Keep in mind right now, I'm actually at the maximum lift on the camshaft over here. So that would give me a maximum lift on the valve opening right here. So if we go back in the reverse position, you'll see that this little surface over here is what's used to press this roller arm down. This is now going to its minimum most position. So essentially we're using that eccentric shaft kind of like a throttle body and not allowing any air to enter once it's in its minimum most position. For example, right now we're at the maximum camshaft level and I can move this and the valve is not moving at all. And that's because of the way the geometry is set up. Alright, moving to the front here, the proper way to do this would be to set your timing and put your timing tools in so nothing collides. Finally found a use for my brand new 27mm socket, and that's to take off the timing chain tensioner. Pull that out. It's spring loaded, but it's also hydraulic as well. Oil is going to go in here and push that piston out. Oh crap. Now we got less tension here so we can take off the gears. This is the oil control valve, and if you remember, that actuator is going to push down and that's going to allow more oil to go in and fill up this gear to advance or retard timing. So let me pull off this gear from the shaft. Pull this guy off as well. We got to take our sensors out. Now I should have enough space to take out the intake gear here and the exhaust gear here. You could see how this is already getting complicated to time this thing. Okay, on the head there's this hex socket over here, 8mm. I already loosened this before I put this on the stand. Whoa, that's a long crank bolt. Pull this off. That also has a timing gear on it. I guess I wasn't supposed to do that. Right now at the bottom here we do have two more hex plugs. Two bolts at the bottom here, T45s. I was able to use an H5 hex to break this free because I don't have the socket for this. Okay. Now, because we don't have a timing cover, we have to slide this timing cassette out. It's very rare to be sliding a timing cassette out of an N20 in one piece, but that's how it goes in. So I'm guessing it's not a timing chain guide related failure because everything here looks intact. I'm going to start getting some of this Valvematic stuff off, even though you don't need to get the head off. Let's get these E10s off. Take these blocks off. Next I'm going to take the spring out. Then this intermediary roller. Intermediary roller will roll on the surface of that block that I just took off back and forth. Next up I'm going to remove all these T30s that hold the camshaft on. Ooh, they do have quite some lines on there. Might indicate an oil failure. Grab my wife's 90 because cotton is always good to absorb oil. Take a look at those bearing surfaces. Wow, look at that. Quite scored up, especially the ones in the middle here. Definitely an oiling failure. Let's get this exhaust camshaft out of the way. Alrighty. So there's this oil pipe that takes oil from the head over here, brings it over to the back of the head, and it kind of lines up with the back lobe over here. Not as bad as the intake camshaft at all. I can see if I can get this Valvematic eccentric camshaft. Eccentric cam has these two stoppers on there. That motor looks like it's in the way. So I was able to free the motor to come up. And I can take off the electric motor. Here we have the eccentric shaft that it spins. You can see this is using a spiral gear against this half moon. So that's great because it can't allow it to return on itself because this won't be able to spin that spiral. Also note this eccentric shaft is using this roller bearings unlike the camshaft, but these are also oiled just like the camshaft. And these are what the lobes look like. They're not pointed like how the camshafts are pointed. Now the rest of this actually looks like one casting inside of the head. So we've got our normal little rollers that actually press down on the valve, and we have hydraulic plungers underneath them. They sit inside of an oil cavity that's going to be supplied with hydraulic pressure when the engine is on, and that takes up any slack between the whole roller rocker arm system. Okay, the outside head bolts on these are T55. And yes, that is a 3/4 breaker bar with a 1/2" reduction with a 3/8 reduction to my T55 socket. Now the head bolts in the middle are T60 Torx. There's also some E12 head bolts inside of the timing chain cover. I find the smaller brushless motor does better than the bigger, older brushless motor. I'm gonna zip these off. Now before we could take the head off, I need to talk about the turbocharger, which was another soft spot on these N20 engines, mostly to do with the wastegate rattling away. This one here has an electronic wastegate that connects up to here. We do have our coolant lines that come in here. We do have our oil lines coming in and draining out this way. Essentially, we've got air that comes in through here, gets spun up by the turbocharger, and boosted air is sent out towards the intercooler this way. We've got hot exhaust gases flowing out this way that's going to turn that turbine, and then the catalytic converter is going to bolt up over here. Now this was a mid-mileage engine, and you could see that the turbo is actually worn down and it's moving significantly. That means it's just going to be touching the housing, scraping away at it, and eventually lose pressure. Here's a look at the play from the intake side. You can see that the turbine is moving around. It has too much play. The wastegate itself has a little bit of play on it as well. Now one thing I do appreciate about German engineering is that the packaging here is really nice and tight. They've sort of fit the turbo inside of this cavity area in the engine block, and it's not just sticking out like the old school cars. Get the turbocharger off of here. These are again 11mm bolts. Now I like how the nuts are nice and tall. That means your socket isn't going to strip on something very thin, and you can really get the socket on there, especially because BMW knows these turbos are not reliable, and you're going to be putting one of these on in the lifetime of the vehicle anyway. A couple of brackets down here. Oil line to unbolt. Things off here. See if we can get off this bolt here. Cooling lines. Hey. Alright, now let's see if the turbo is going to come off. I did miss a head bolt over here. Now it's not fair to jump to conclusions, but this head gasket area looks a little burnt, and it does not look like the other two. The story's the same on the back of the head here. You can see those ones look great, but the 1 and 2 looks a little bit sus. Now coolant going to the turbo lines over here is a little bit interesting. It just grabs this coolant coming from the inlet over here, cools it off, and just spits it back out into the same cavity. Kind of a short circuit to me. It doesn't really make sense. You usually want it to go from cold side to warm side. Alright, time to make some mess and turn this upside down. And here we come to one of the biggest gripes in modern BMW engines, and that's his plastic oil pan. The reason is because they warp, they crack, and they'll leak. The other thing is the drain plug itself is also made of plastic, which means that, as you can see here, it's already stripped out, and you're going to have to be replacing these periodically if it's not already a wear item. Now it's great that you can use plastic. You can optimize the shape for whatever sits under here, likely the differential and the axle, because this was an X3. But here's a bigger gripe. This is an engine level sensor. That means you don't have any dipstick on this car. How are you supposed to check oil? Well, you're supposed to use a multimedia interface inside of the vehicle to check and see if you need to add or remove a quart. It's kind of annoying because you can't really check the quality of the oil. Say if you got a head gasket leak like this one, and coolant has filled up your oil, or it's all frothy. These sensors also do fail from time to time, and as you can see, this one's also leaking, and they're more expensive to replace than a dollar dipstick. Looks like this pan has been off already for the diagnostic. Alright, let's see what lies within this plastic oil pan here. This thing's actually super light, and that's another reason why the manufacturers are using it. So taking a look inside this oil pan, it does have a little bit of a milkiness to it. You can see this here is where the oil level sensor is going to stick up, and that'll be your oil level, and this would be the drain port. Taking a look inside here, we've got an oil pump chain, and you can see it's got a hydraulic tensioner, and that's going to push up against it here. This bolt here connects to a shaft that comes back to this giant oil pump assembly. The oil pickup tube would likely have plugged into here, but it looks like it's been missing. Alright, there's a couple of bolts holding this assembly on. Now we got the bottom end, and that looks roasted. No stereotypes intended, but damn, that looks black. Now as you can see, the crankshaft is pretty dark, and that's because it probably ran low on oil and just burnt up. I'm going to relax these E12 bolts here from the connecting rod that I can actually get access to. Okay, I'm going to assume there was some kind of a thread locker or plastic that sits around there. That's just crusting off, but it looks like the metal in the bolt itself looks fine. Now I'm going to use my surgical instruments to very carefully see if this engine will turn. Okay, I think we can remove the lower oil pan after I come back from the break. Next up, we're going to work on getting this upper oil pan off. It's held in by a bunch of E12s going all the way around, as well as these main cap bolts. Main caps on these are 17mm bolts. Time to see if we've missed any bolts. Here is the rear main seal. Okay, I'll get that out. Here's the front seal. Now let's get the final connecting rod bolts out of here. So one thing I like about inline 4s and inline 6s is that you can access all the connecting rod bolts. It's not at some different angle like in a V engine. Alright, let's hammer some of this off here. It's just so dark. I wonder if it's like heat treated like that. These two middle ones are like frozen to the crank. Okay. Then the old 90 pajama here. Clean up these bearings. I think these are also in rough shape. As you can see, the main bearing on the middle here looks a little rough. It's kind of worn down. The real story is over here, guys. This is, oh man, that was seized on there. If I can get this one out. Connecting rod cap is just fused. There we go. It seems like all of the connecting rod bearings are fused onto the crankshaft. So I'm going to see if I can unfuse them. And here we have the results. You can see some of the connecting rod bearings that I was actually able to peel off. You can see the rest of them are still on there and they can't come off. They're just seized to the crankshaft. That's because somebody ran this engine without oil at all. Maybe they forgot to fill it up before driving away from Iffy Loop. Now the reason I say no oil is because we didn't see much failure in the top end. All the chains and everything was intact. When you run an engine low on oil, the first thing to get oil are these main bearings and then the connecting rod bearings, which is why they fail first if you start to lose oil pressure. I mean, this is just so sad. It's worn through the metal. It should be looking something more shinier like this. I did find two more main bearings on this crankshaft and they're not looking very good either. My theory about this being so black is actually true. That's because it got so worn down and so hot, it just cooked the connecting rod caps as well and parts of the crankshaft that connect to it. The sad part is this could have been easily avoided if there was like a dummy sensor built in somehow, you know, maybe like an oil level sensor that would actually shut the engine off when it senses this kind of load. These sensors don't always work. Moreover, it also takes the smartness of the driver itself to actually recognize what the car is trying to tell you and pull over before more damage like this occurs. I'm going to push these pistons through. Quite violent. So check out the difference between the brown color of the piston at the top compared to the connecting rod near the bottom and how black it is. That gives you an idea of how hot this thing got as it was burning up in this area. And I'm surprised to say that there's barely any carbon inside of the oil control ring over here. It's nice and clean, indicating maybe this engine wasn't even burning oil. Piston tops are very black and they do have the cutouts for the valves. But moreover, since this is a direct injection engine, it's got this big bowl over here to help with the combustion. There is a bit of crust along the top edge though. So now I've taken this N20 engine apart. Let's take a look at how the lubrication system works. Starting of course with the oil pump. The oil pump is going to draw in oil through the pickup tube, which would be plugged into here, and that's going to create fluid flow. This is also a balance shaft assembly inside of here. The key thing here is that there's actually two outputs, one at the back here and one at the front here. Now the one at the rear leads to what's very likely an oil control switch, and then it goes back up to the top here. The one at the front here goes to this much larger oil galley that heads to the block. With the block here, we've got the giant oil galley that's heading towards the oil filter, which is actually attached to the head. And at the back here, we've got these two little holes that come from that oil control switch and go into an oil galley that runs along the length of the block. You can see the extrusion of that oil galley running along the length here with your oil pressure switch. Now, the top of the block here, this is the supply area that goes to the head, and this is where you drain back that goes into the timing cover. The head here, you see, we've got our supply over here. And then we've got our filter oil that's going to go back in with that filter assembly that bolts on. Oil filter assembly's got an anti-drain back valve on it. Plus it's also got its normal bypass valve in case it does get clogged. As you can see, oil will go in and then come out through this area here and then go into the head. Oil going into the head here is then going to be split off into two rows here, which are going to power these hydraulic adjusters respectively. Now those two lines are also going to come through these two holes here to go back into the block. And that's where I don't like this design. We've got multiple interfaces and the fact that the oil has to go first through the head and then come back to the block to recirculate oil. I think it's a lot of interfaces that could potentially fail and cause you loss in oil pressure. Now oil from the head is going to come back down to two oil galleys that run along the length of the block. You can kind of see where they were drilled over here, and they'll have oil sprayers running along the bottom one that's going to line the cylinder walls with oil for cooling and lubrication. And then we've got these holes drilled into the upper one over here for lubricating the crankshaft and connecting rod bearings. Let's take this oil pump apart so we can see what's inside. Sure, there's the balance shaft assembly in here. This is a T55. Okay, stuck a bar in there. Got the bolt loose. Get these T30s off. Timing chain slide, surprisingly not fail. And this here is the hydraulic tensioner. You can see it does have a spring inside, but on the back of it here, it also takes oil pressure from this hole here. Next up, I'm going to remove all these T30s on the back side. Let's just going to separate what looks like the oil pump side from the balance shaft side. This here is a look at the balance shaft assembly. There's two shafts over here, and they have two half weights on them over here that are opposing to each other. But because this is a rattly 4-cylinder and it's a BMW, they wanted to smoothen things out slightly, even though the N20s are known to not be nearly as smooth as their inline 6 predecessors. On the back side of the oil pump, we have the drive wheel. It comes from that balance shaft, and let's open this up here to see what's inside. Looks like we got a little spring in here. Yeah, that is a check bulb. Now the oil pump on these are a vane style oil pump. You can see as I rotate this how it works. Now this is a variable style oil pump, which means that you've got this large spring here that makes the housing offset and eccentric, and that's what gives you this giant gap over here, allowing you to move lots and lots of oil. Now if I do apply some oil pressure on this side, it's going to push up against that spring and make this more centered, and that means that the gap on this side is going to equal the gap on this side, and we're going to move less oil for more efficiency. Now the oil control valve on the side of the upper oil pan is what's going to control the amount of oil on this side, and therefore how much oil this thing is pumping out. If you can pop this all apart here, let's get the spring out of there if we can. So to my very surprise, this is actually made of plastic. It's very light. Now if you do have debris running through here, it will wear out, but as long as the oil is clean and very well filtered, it probably won't wear fast enough more than the rest of the BMW. To be truthfully honest, there's actually not that much wear inside of here, especially given that connecting rod bearing failure. Next up we have the engine head, and as you can see we've got direct injection on here, with the injector sitting over here right next to the spark plugs. The intake valves are on the bottom here, and the exhaust valves are over at the top here. Sounds great, right? Well, with direct injection you can control the combustion a lot better and gain better fuel economy and less emissions. But the expense would be the back of these intake valves, so let's take a couple of them out and see how bad they are after 230,000 kilometers. I find it very weird that they've cast this ValveTronic piece on and not just made it a bolted on piece. Now with BMWs you need special tools for everything, and in this case you need a special tool to remove the valve. But I've got my special tool right here. Alright, let's pull these valves out. So here's what the back of the intake valves look like across all 4 cylinders. You can see it's this really hard sticky stuff. It's not just something that'll scrape off very easily. You'd need to soak this in some solution or do a walnut blast on this to get this off. And of course the reason why these BMWs are doing it is because they only have direct injection. There's no port injection outside the airstream that'll put gasoline behind these valves to wash them off, because gasoline is an excellent cleaner. Having too much carbon buildup behind these valves are eventually going to be like having a COVID mask on. You could barely breathe. And then it'll cause things like rough running and misfires, which we don't want to deal with, so why not just use dual injection anyway? Yeah, I get it, and that's the whole reason why we went to a 2-liter 4-cylinder instead of a 3-liter inline 6 for our base model BMW engines, and that's because we just wanted to save money and save fuel. And of course saving money means skimping out on things like this at the expense of your higher mileage owners that have to deal with this. And that's a look at the BMW N20 4-cylinder engine. Now if you do have one of these engines and you don't want to have an oiling failure or any of the other common issues with this engine, make sure you figure out how to check your oil through the multimedia interface and double your oil change intervals from what the manufacturer has suggested. Now make sure you support me on Patreon and subscribe for more videos just like this one.